We're going to be continuing with our properties of logarithms. A couple new things to add to our list of properties here. Before we get into that though, there is just one thing that I want to talk about. This is called the change of base formula. There are some calculators that can't evaluate logs of any base. There are other calculators that can. It just depends on your calculator type. However, most calculators have a log button and a natural log button, or LN. So if you don't have a calculator that can evaluate this as is, then what you have to do is you have to use this change of base formula. And essentially we're going to either convert this to a quotient using the common log, or we can do the exact same thing but use a natural log instead. So what you're going to do is you're going to take your input value, so in other words 25 here, and you're going to say log base 10 of 25, or just log. Log base 10 is implied that it's just the common log. And then you're going to take that base value and you're going to evaluate the log of that value as well. In the past, I usually confuse myself as to what to put on top and bottom when I'm doing this formula. So if you just remember that the base number is going to be the one that goes on the bottom, then that should make sense. Put the base on the bottom, and then you'll remember to put the input on top. So using your calculator and using the log button, evaluate log of 25 and divide that by log of 4. And you should get a decimal that's equivalent to approximately 2.322. We can do the exact same thing but use a natural log instead and press the LN button. So again, we're going to take the natural log of 25 and divide it by the natural log of 4, and you should get the exact same answer. And if your calculator does allow you to evaluate this log base 4 of 25, you should see that it also gives you the exact same value. So it really doesn't matter how we change our base here, as long as we are using a quotient that has the same base. But obviously if your calculator can't evaluate it as is here, then you're going to want to use either the common log button or the natural log button to do it. Alright, on to some more properties. Here we got three more, a little bit more complicated properties than in the last video. We're going to use the product property. We're going to take a number and we're going to expand it into a product of two numbers, and that will allow us to expand that into a sum of two logs. Similarly, but slightly different with the quotient property, if we have log of some sort of quotient, like a fraction maybe, then we're allowed to break that up and use those two numbers, give them each their own log, and subtract between them. And lastly, with the power property, we're going to take a log of a number. If that number is raised to an exponent, what we're allowed to do is just take that exponent and move it to the front, and now it's a multiplier. All right, let's practice using these properties. A couple of simple, straightforward examples to start with. If I want to take 6 and expand it into the natural log of 2 plus the natural log of 3, well, what step in between that's missing would be taking that 6 and expanding it into the product of 2 times 3. So now that it's a product of two numbers, I can give each of those two numbers their own natural log and put an addition sign in between. In this next one, we see that e is being raised to a power, so we're going to use this power property. And we're going to take that exponent, we're just going to move it to the front, now it's a multiplier, and that allows us to simplify the natural log of e, which is always 1, and 5 times 1 is 5. Let's do a few more examples, a little bit more complicated. In part A, we have a quotient. We're trying to take the log base 10 of this quotient 9 divided by 125, so we're going to use the quotient property. So we're going to take that top number.
Connor Fearing, please report to the West Campus main office. Connor Fearing, report to the West Campus main office, please.
Pardon the interruption there. We're going to take that log base and we're going to give it to the top number and we're going to give it to the bottom number. So we're going to take log base 10 and assign it to 9, so log base 10 of 9. And we're going to take that log base 10 and assign it to 125, so log base 10 of 125, and we're going to put a subtraction sign in between it. Next one, stepping it up, slightly more difficult still. This time we have 3 terms here that are all being multiplied. So we're going to apply that product property a couple of different times here. Well, 3 different times. So make sure you can recognize that each term here is 5. We got x cubed and we got y. So we're going to give each of those 3 terms their own log base 4. So we got log base 4 of 5. We got log base 4 of x cubed. And we have log base 4 of y. One more step we can do to expand just slightly is this variable has an exponent, so we can also use that power property and take that exponent, move it to the front as a multiplier instead. So we're going to keep the exact same first term, log base 4 of 5, but now we're going to take that 3, move it to the front, so that now we have 3 times the log base 4 of just x, and keep that last term the same, log base 4 of y. We're putting addition signs in between each of them. One more time, last example expanding here. We got a quotient. So we're going to take the top, we're going to give it its own natural log. We're going to take the bottom, give it its own natural log, and put a subtraction sign in between. Anytime we have radicals, we want to rewrite them as exponents so that we can use that power rule. So a square root is the same as a power of 1/2. Now that we have an exponent, use the exponent or power rule and move that exponent to the front so it's a multiplier instead. So now we have 1/2 in the front times the natural log of the quantity 3x minus 5 minus the natural log of 7. If we can expand, well then we can work backwards and take an expansion and do what's called a condensing. We're going to condense or shrink each expression and make it more simplified. First, you always want to look for any coefficients, those multipliers that we can rewrite as exponents using the power rule. So we got 1/2 times log base 10 of x. We're going to take that 1/2 and move it up to be the power of our input there. So now we have log base 10 of x to the 1/2 power. On the next term, we have 3 times log base 10 of the quantity x plus 1. So we'll take that 3 and we'll make it the exponent of our input or quantity x plus 1. So now we have log base 10 of the quantity x plus 1 raised to the 3rd power. We'll put an addition sign in between them using, well, we haven't used it yet, but we're about to use the product property. We got the addition. So we're going to take our inputs now and we're going to put them together as products instead and only use one log. So we got log base 10 and we're going to take x to the 1/2 and multiply it by x plus 3 to the 3rd power or cubed. And one last thing we could do, we could write it as x to the 1/2 here, or we could change it to its radical form. I prefer the exponent form, but I know that a lot of textbooks or worksheets prefer to rewrite it in that radical form. All right, part B. We have a difference here. So that must mean that we're going to use the quotient property, but before we do that, let's check and make sure that we can apply the power property. We have a coefficient here, or a multiplier, so we're going to move that to the exponent position for our input. So instead of 2 times the natural log of x plus 2, now we have the natural log of the quantity x plus 2 squared. We have a difference between 2 logs, so we'll use that quotient property to rewrite it as a quotient instead. So now we have the natural log, just written once, of the quotient, the quantity x plus 2 squared divided by x. Last one gets a little trickier still. This time we have 2 logs here, and we have a multiplier out front of both of them. So because we have these brackets here, that means that 1/3 is being distributed or multiplied to both of these logs. So you could distribute it first and then use the power property, but I'm going to do a little shortcut here. I'm just going to simplify the inside first, and then I'll bring that 1/3 back in. So we have a sum here, so we can rewrite that as a product. So because we both have log base 2 here, then we're allowed to rewrite it as just 1 log base 2 of the product x times the quantity x minus 4. You could distribute that in, but we never want to do that in case we're having to solve. We want to find those zeros using that factored form. It's a little easier. So just keep it in this form. Now we only have one log being multiplied by 1/3, so now we can apply that power property and move that 1/3 up to the exponent position of our inputs. So this large quantity here is just our input. And we could rewrite that, although I prefer that form. We could rewrite 1/3 as the cube root and put the cube root around your inputs there. Don't put it around the log, it's only applying to the inputs there. All right, so a few examples there using those properties to condense or expand. We're going to need those skills in our next lesson when we solve exponential and logarithmic equations. So being able to rewrite is going to help us solve. Practice rewriting using those properties.